Have you ever stopped for a moment in the middle of winter, looked up at the sky, and noticed snow falling so quietly it almost feels like time is slowing down? Each tiny flake drifting through the air looks delicate, perfect, almost designed, and yet no two of them are ever the same. Not once in all of human observation has anyone confirmed finding two identical snowflakes. So here's the question that takes us into today's journey. How can nature create something so beautifully complex, billions of times over, and never repeat itself? Welcome to Science Meets Adventure, the channel where science isn't just explained, it's explored through travel, nature, and discovery. Today, we're going on a journey into the heart of winter storms, inside clouds high above frozen mountains, and deep into the invisible rules of physics that shape every single snowflake that has ever fallen. Let's begin far above the ground, inside a cloud. A snowflake doesn't start as a crystal. It starts as something far simpler, a tiny particle floating in the atmosphere, like dust or pollen. This particle becomes the foundation for something extraordinary. When the temperature drops below freezing, water vapor in the cloud doesn't turn into liquid water first. Instead, it transforms directly into ice. This process is called deposition. And right there, in that moment, the birth of a snowflake begins. At first, the structure is incredibly simple. Water molecules begin arranging themselves into a hexagonal pattern, 6 sides, perfectly symmetrical. This happens because of the natural way hydrogen and oxygen atoms bond together. So every snowflake starts with the same fundamental geometry, a 6-sided crystal. But from this point onward, the story becomes anything but uniform. As the crystal falls through the cloud, it enters a constantly changing environment. It is not falling through still air, it is traveling through layers of different temperatures, humidity levels, and air pressures. And each of these conditions changes how the snowflake grows. In slightly warmer parts of the cloud, the crystal may grow wider, forming flat, plate-like shapes. In colder regions, it may stretch outward into long, needle-like structures. When humidity is high, branching arms begin to form, creating intricate patterns that resemble frozen trees or fractals. When humidity drops, growth slows and the structure becomes simpler. Every second, the snowflake is being reshaped by its environment. Now imagine this happening inside a turbulent storm system, where air currents are constantly shifting. A snowflake might rise, fall, spin, or drift sideways. It might pass through multiple layers of temperature change in just minutes. No two snowflakes experience the same path. And this is one of the key reasons why no two snowflakes are ever identical. Even if two crystals start forming at the exact same time, in the exact same cloud, they will still be separated by microscopic differences in their journey. One might encounter slightly more moisture. Another might pass through a colder air pocket. Another might rotate differently as it falls. And at the molecular level, there is even more randomness. As water molecules attach themselves to the growing crystal, they do not land in perfectly identical positions every time. These tiny variations accumulate. Over time, they create completely different branching patterns. Small differences become large structures. Minute changes become unique designs. It is chaos and order working together at the same time. Now, if you want to see this process in the real world, you don't need a laboratory. You need to travel. Picture yourself standing in a high mountain range where clouds move just above your head. In places like the Himalayas or the Alps, snow is not just something that falls, it is something that forms all around you in real time. Or imagine polar regions, where the air is so cold and dry that snow crystals form with extreme precision. In these environments, snowflakes are constantly being created, each one shaped by forces you cannot see but can absolutely feel. Even a quiet winter walk in a forest becomes a scientific experience. If you stop and observe a fresh snowfall closely, you might notice the branching patterns of individual flakes resting on your sleeve or glove. Each one a tiny frozen structure that existed for only a few minutes before reaching you. And then it disappears. Here's something even more astonishing. The number of possible snowflake shapes is essentially infinite. A single snowflake contains billions of water molecules, and each molecule can arrange itself in countless ways depending on its environment. That means nature has an almost limitless design space. Every snowflake is a unique solution to the same physical conditions of temperature, humidity, and time. Some are simple and elegant. Others are complex, with branching symmetry that looks almost mathematical in its precision. Yet all of them follow the same fundamental rules of physics. So when you look at snow falling, you are not just seeing weather. You are witnessing an enormous, invisible experiment unfolding in real time, one where nature never repeats itself even once. Every snowflake is a frozen record of its journey through the sky, a journey shaped by physics, chaos, and chance, but resulting in something undeniably beautiful. And that is what makes snowflakes so extraordinary. They remind us that even in a world governed by laws and equations, there is still endless room for uniqueness, variation, and wonder. So the next time you see snow falling, take a moment to really look. Because what you're seeing has never happened before and will never happen again. If you enjoyed this journey into the science of snowflakes, don't forget to like, share, and subscribe to Science Meets Adventure for more explorations where science meets the wild.